Okay, so we're looking at time series now, time series data. So with time series data, it is a scatter plot, and except that we're going to have time along the explanatory variable. So time will have to be put in as a number. So if we've got in the example here, we've got like 2011, 2012. So we can use that as a number, and we can do that with a time series. We may get something like, so say for example, we might look at, say, the months of the year. So say January, February, March, April, May, June, July, August, etc., like that. Okay, so say we were talking about, I don't know how many sunny days there were every month. And so then I had the data underneath. So say, I'm making this up. So 9, 10, 2, 3, 1, 5, whatever, 4. So when we have that, for instance, what we need to do is we have to create a time code. Because we want to do a scatter plot, and a scatter plot is numerical data. So what we do is we create a time code, and we'll just call our first month number 1, and so on like that, and it would keep on going onwards like that. So when we have a time series, if we're given things like that, or it could be we might be doing days of a week, and we might do a couple of days. We're just going to call day 1 to begin with, and we keep counting the days. All right, so that's what time series is. It is a scatter plot, and we'll be looking at something, within the time. Okay, so on your calculator, you create it as the same way in terms of you create a scatter plot. And then once you've done the scatter plot, you've picked your year, and say this was the year and the birth, and I think the number of births. Once you've done that, you can connect the dots. So you can see on the scatter plot, the dots are connected. So in a time series, we connect the dots. So it means we draw a line in between them. But your calculator can do that too. Just press menu, and it'll say plot properties. So you might just want to write that under plot properties. It will allow you to connect the dots, okay? So now we've got these time series, we have to look for certain things. So things we are looking for in the time series is a trend. So a trend is it overall going upwards, so an upward trend, or is it maybe overall going downwards? Or there might not be any trend at all that way, in terms of it might not be changing. So we might not comment on that either. We're going to look at things called cycles. So cycles, just to maybe while you're here, it's over many years. So what we might see, so every 10 years we see, something happens. So say unemployment rates, we might notice every 10 years we get a real drop in it happening. We might say that's a cyclic. When you have seasonality means you're seeing a pattern within. It could be like you might see it quarterly, but it could be, say, the days of the week, where we might see every Wednesday something happening. So it's on a more smaller scale, and don't worry, so it's like a smaller scale. And you might see something happening every particular same day or same month or same quarter is happening. Okay, structural change, we're just going to see things changing, like we might see a massive increase at just one-off. That would be a structural change, and some possible outliers. This irregular fluctuation, you're going to always see that in a time series if they're using real data, generally. I shouldn't say always, because sometimes I think they've shown a heartbeat monogram or something. That's a time series, yeah, and maybe your heart might be in a regular pattern, but very rarely. Most data we're looking at there was random fluctuations, and we'll have a look at it. Okay, so, I've repeated that bit there. So here, the first thing we're going to look at is trend here. So examining the time series plot, we can often see if there's a general upward or downward trend over time. This indicates a long-term change so you've got to see it over a long time, like a period of time. Trend lines have been drawn on time series to below to help you indicate. So what you have to be careful with, and I'll show you when I do the exam questions, is sometimes they'll say pick the last dot and the first dot and put a line in between it. And if you can see overall it's going up, then it's going up. What you're going to be careful is make sure it's the same time of the year, or the same time. If you've started at January and you want to go to the end of your data, make sure you're in a January later on, because otherwise we could have peaking in between the year, and it could. So there's a general downward trend, and then this one underneath shows you that we had a few trends over time. So you might comment on that if you were looking at it. So if you get a SAC and you get some data, you might say, yes, the overall trend, we can see an increase of happening, okay? So that's trend. Cycles, as I said before, cycles are a recurrent movement in a time series, generally over a period of greater than 1 year. So generally, it's even more than that. You'll see big chunks. So can you see this? And it's a little giveaway on what type of data you're looking at. Okay, so looking at this cyclic one, can you see, like, we're talking about it's every 10 years going along here. But what they were looking at is sunspots on the surface of the sun. So this is getting recorded for years and years. But you can see every 10 years or something, we get a drop. So you could see every 10 years it drops in the number of spots. So we can see it's over a big time period, but the same thing's happening. That would be cyclic. Okay. So seasonality is when it's in a smaller period. So you'll see things, for example, a year. It could happen. You might see something that's happening every month. That would be seasonality. You could have it happening every quarter. Something drops, or it happens. That's seasonality. Or even if you have like 7 days of the week and we see something happen every Wednesday, that's seasonality as well. Don't get confused with the word seasonality, meaning summer, autumn, winter, spring. It can be, we might see a trend happening in those seasons, and we would call it seasonality. But if I had days of the week and I had something happening every Wednesday, that's seasonality as well. Okay, so if you look at this example down here, they're talking about seasonality, but they've got the years, but you can see it's in quarters, like broken up into quarters. So what you want to do is you have a look at it, and you can see every June, see how it's dropping every June? So we would say that's seasonality. Something's happening, whatever this was. It was room occupancy in a hotel, I think. So obviously June might have been winter season. We would expect it to be dropping. And you can see it's peaking in the September, December. Yep, so thing. So have a think about your data when you're getting it, and think logically, because we use real data, and your logic answer, will help you decide. Okay, so structural change, we mentioned about it. So say here, we might just say, see, there was a sudden drop here. So we just say if we were describing this time series, we just say, look, we might say an overall downward trend with a major structure change between June and July. Okay, so that you might comment on that. Outliers, so here we can see it was generally hovering around the same. Something happened on day 4 to cause a big structural change. So it could be an error. Could be an error in collecting data, who knows? But there you go, you just make a comment of that. as I said, that last one, everyone would have random fluctuations. See the one above? It has random fluctuations. It's not perfectly going up and down. They're all sort of moving around differently, slightly, and so on. Okay, so nearly almost everyone, but I don't like to say almost every, like we shouldn't really say it always is, because as I said, you could get a heart monogram or whatever they do, and it would produce a perfect pattern, yeah? So, and that's a time series over time. Okay, so this is where you're gonna have to, this is where you learn the most about it, is doing the actual exam questions for these. So with this first one, it says consider the time series plot below. So you see it's going up into the months. So what you do, I think the best way to do it is to break these it's a year, so they're breaking up the months. So if you have a look, you go 1, 2, 3, 4, 5, 6, and see how on the 6th month it dropped. Now when you're in the second year, if you counted them out again, so 1, 2, 3, 4, 5, 6, you can see on the 6th month again it drops. So I'm breaking it up into those months, those 12 months, and I'm seeing the pattern that it's dropping every 6 months. So this one has the dropping every 6 months is indicating seasonality. That is seasonality. Now, what we want to do is we want to see, is it overall dropping or increasing or dropping? Be careful with this one. So when you do this, sorry, I'm just going to draw a line here and move it so you can see what I'm talking about. So, see, sorry boys, see with this ruler, this is my green line, the ruler. What you want to do, if you did a line through the first and last dot, it may seem that it's actually increasing a little bit. But it isn't. If you look at it, because we've already marked out the 6th month of everything, draw a line through the 6th. Now, if I go through the 6th month every time, is it going up or down? It's not really, is it? It's hovering around the same. So even though we do peak in the seasonality, overall it's staying around the same area. So there's only seasonality. Now, is this a perfect pattern? No. So it has that irregular fluctuation. So if we're looking at this, what one are we going to say? C. Good. Seasonality with irregular fluctuations. Okay, with this next one, the wind speed at a city location is measured throughout the day. Okay, and the time series plot is shown here. Okay, so we want to do, it wants you to describe this. This is how most of our exam questions are set out. Alright, so what I want you to do with this one is like what I was talking about before. Let's go through, they're talking about days of the week. So if I go 1, 2, 3, 4, 5, 6, there would be 7. Then 1, 2, 3, 4, 5, 6, that would be 7. 1, 2, 3, 4, 5, 6. So what you would look at is, all right, I saw here between 2 and 3 we had a little bit of a flat. But then if I go to the next 2 and 3, we decrease. So that's not similar, is it? Or then if we go to the next one, so there's no seasonality. Is it doing the same thing at the same days? No. If you quickly had a look at it, it might look like it. There might seem like there's a bit of pattern. So there's no seasonality there. And is it, so what am I going to say? Probably the only good thing to say about it is, yeah, increasing. Because if you look at day 1, let's just look at day 1. Do you think it's increasing? Here's day 1, day 1, day 1. I reckon it's not. It's sort of plateauing. So I think the best answer for this one is actually just irregular fluctuations. If you look at the same day every time, it's not really moving. It's moving all over the place, but it's going up and down. So we're not seeing an overall upward trend. Okay, so check the same day. So when you're looking for that upward and downward trend, pick a day and see, did it move consistently up or down over the whole period? And this one's not, it's all random. So this one would just be random fluctuations. Okay, this next one. The time series below shows the quarterly sales in thousands of dollars of a small business for the years 2010 to 2020. Okay, because we can see within the year here, so we can see that those years, they're breaking them up into quarters. So we're not going to say if there's a pattern within there, it's probably seasonality. There's not enough years. It's not a big years enough to really say it's cyclic, okay? So let's have a look first. So if we look at, so that's what I'm saying. So break this up. It's quarter 1, quarter 2, quarter 3. 1, 2, 3, 4. Then you got 1, 2, 3, 4. So 1, 2, 3, 4. So, okay. So if you have a look at that, what we're going to check, do we see any seasonality? So what that means is we're seeing the same thing every time. So if I just pick the 4, so the 4 dropped there, but then this time it's up, and then the next time it was up, and then if you go there, then it's down. So it's not doing the same thing, is it? There's no seasonality in this one. I'm going to say no seasonality. There's definitely irregular fluctuations. Now, so the only other thing is, so I'm getting rid of it's not seasonality only. Now, the other thing is, now I'm going to look and see if we've got a downward or upward trend. So what I'm going to look at is make sure I'm looking at the same, if you're at the beginning of the year and the start of the year. So if you had a look, we were on, like, say, season or quarter 1 here at the beginning, and then if you go quarter 1, so on. But then when we get up to 2020, or even if we go to 2019, let's go quarter 1, we have probably got a decreasing trend there, because overall we're sort of starting to drop down a little bit. It's not huge, but it is probably overall going down. So I'm going to go with a decreasing trend with irregular fluctuations. I definitely knew it was not seasonality, getting rid of that. Irregular fluctuations only, maybe. We know it's not seasonality, so we get rid of that. So can you see it? The graph is sort of going down overall. It's slightly going down, but it is going down. Just make sure you check the beginning of a year, and also you're still at the beginning of the year when you're doing it. Don't check different quarters. Okay, that's that one. With this next one, a time series plot shows the number of passengers who flew in an airline each month over the period of 1955 to 1960. Just think, if we're talking about airline passengers, when do you guys all go on the plane? I bet you near the end of the year we're all going away on our holidays. There's higher flights, isn't there, around Christmas time and all that? So do you think we are going to see some seasonality? Yeah, I would predict too. Now, can you see we are peaking within the year every time? Yeah? So this one has seasonality. Is it a perfect pattern? Not really. So there we'll have irregular. So, but is it overall? Do you think it's going up? Yeah. So which one is this one? E. Yeah? Increasing trend with seasonality and irregular fluctuations. Okay? You can always eliminate one that you think, oh, well, maybe no, and then you should be able to eliminate all of them. All right, the next one, this one here, it says house sales in the thousands. The pattern in the time series plot is best described as. So what do you think this one? If you look at it, it doesn't look like it's doing the same thing on every day. If you it's breaking up the years in roughly quarters. Is it happening at the same time? Not really. Oh, you reckon it is?
4, 8, 12, 16 all increase.
4. Okay, alright, good. So we think that it is. Awesome. Because it's every 4, let's say then it's seasonality. So, but would it also be increasing? Yeah, I would go. So we're going to go with D. Good. Good work. Okay, someone said, shouldn't you have irregular fluctuations? It does, but it says it's best described as. So we're going to go with the best answer. Is it seasonality only? No. Decreasing trend? Definitely not. Cyclic? No, it's not enough. It's happening within a year. The pattern's happening within the year. So the rest, so D is our best answer. All right, the time series plot charts quarterly sales figures in the millions of dollars of small manufacturing businesses for 4 years. So let's have a look. Is it peaking? Is it doing the same thing every quarter? Yeah, so we're going to say it's seasonality. But when I did that, do my dots look like they're increasing or decreasing? Not really. So what do we think this one would be? Which one? B. Yeah, seasonality only. There's no increasing trend there. Okay?
No variability.
Okay, the last one. The pattern in this time series, this one here, is best described as... Is this a repeat? Oh, I thought it looked exactly the same. Maybe not. All right, yep. What's it best described as? What do we think?
D.
This one, I think it doesn't peak the same time, does it? No. So I think this one's just A, irregular fluctuations.